Today, y'all are going to solve some systems of linear equations by substitution. I'm going to do a couple of these problems with you. This assignment is due at the end of the class period. Let's start with problem number 1. Number 1 says x plus y equals 8 and y equals 3x. In this problem, the second equation is solved for a variable. Notice we have y equals 3x. So I'm going to substitute 3x in for the y value in the first equation. So I have x plus y equals 8. So I'm going to substitute that 3x in for y. So now I have 1x plus 3x, which is 4x, equals 8. So if I divide both sides by 4, that gives me x is equal to 2. So the x value in this solution is 2. Then to find the y value, I'm going to plug my new x value, x is 2, into either equation. I'm going to plug it into the second equation because it says y equals, and we're looking for y. So y equals 3x, but I found that x is equal to 2, so I can say y is equal to 3 times 2. And 3 times 2 is 6. So my solution is 2, 6. All right, I want you to solve number 2. Let's take a look at number 3. Number 3 says x plus 3 equals y, and 3x plus 4y equals 7. In this problem, the first equation is solved for the variable y. Even though y is written after the equal sign to the right of the equal sign, it's still by itself. It's still isolated, so y is still the variable that's solved in this equation. So I can substitute y into that second equation here. So I'm going to write 3x plus 4y equals 7. And here, y we found in the first equation is x plus 3. So the first thing I did was substitute x plus 3 for y. So now all my variables are the same, they're all x, but I'm going to distribute so that I can solve. So now I've got 3x plus, and I have 4 times x is 4x. 4 times 3 is 12 is equal to 7. Now I can combine like terms. I have like terms here. I have 3x and 4x, which gives me 7x plus 12 is equal to 7. Then to get x by itself, I'm going to do the inverse and subtract 12 from both sides. So now I have 7x is equal to negative 5. So 7x is equal to negative 5. And finally, I can divide both sides by 7. So x is equal to negative 5/7. I'm going to leave this as a fraction. So the x value is negative 5/7. So now to solve for the y value, I'm going to use one of the equations. Let's see, I like the first equation. We have x plus 3 is equal to y. And I like the first equation for a few reasons. Well, it already says y equals, so I know I'm looking for y. It also has fewer coefficients. It's got fewer things that I have to divide or subtract. So I'm going to replace x with negative 5/7 plus 3 is equal to y. So here you can use your calculator. I'm going to solve this by hand. So if I have negative 5/7 plus, and if I want this to be a 7, that's 21/7 equals y. So that's going to be 16, positive 16/7 is equal to y. So my solution for this system will be negative 5/7 and positive 16/7. Let's take a look at number 6. Number 6 has some fractions in it. Number 6 says 3x plus 2y equals 23, and 1/2 x minus 4 equals y. Well, here I have my second equation is solved for y. So I'm going to replace the y in the first equation with that 1/2 x minus 4. So I'm going to say 3x plus 2 times y equals 23. So I'm going to replace where y was with that 1/2 x minus 4. So now I have 3x plus, and I can distribute that 2. So 2 times 1/2, so half of 2 is 1x. And 2 times negative 4 is negative 8. Is equal to 23. So I've substituted, I've done distribution, so now I'm going to combine like terms. So now I have 3x plus 1x is 4x minus 8 is equal to 23. So to get x by itself, I'm going to do the inverse and add 8 to both sides. Scoot this all up because I seem to be running out of room. So now I have 4x is equal to 31. And then I can divide both sides by 4 to solve for x. So 31 over 4 is a decimal, so I can get the decimal, or I can leave it as a fraction, and the directions here say to leave these as fractions. So I'm going to leave my x value as 31 over 4. So my x value is 31 over 4. Now to find the y value, I'm going to plug my x value into one of the equations. Well, if I'm looking for y, one of the equations, the equation we highlighted actually, says y equals. So I'm going to use that one. We could use that top equation. Either one will work. But I like the bottom equation because it seems a little more straightforward. So I'm going to plug in 1/2 times x minus 4 equals y. So I'm going to plug in that x value, that 31/4. So that's going to give me, when I multiply, 31/8 minus 4 equals y. So again, you're welcome to use your calculator for any fractions. I'm going to go ahead and work this out. So I have 31/8 minus 32/8 is equal to y. 31 minus 32 is -1, so I have -1/8 is my y value. So I'm going to plug that in over here. It's -1/8 for my y value. Let's do one more problem. Let's take a look at the back. On the back, I've got 2 more systems that are already written out, and I have one word problem. So on the word problem, I want you to try that one. Let's take a look at the 2 systems. Let's see. Take a look at number 8. Number 8 says y equals -2/3 x minus 4, and x equals -3. Well, right there, that says x equals -3. So I have one of my variables already solved. My x value is -3. We don't have to do anything to find x. My y value, we have to find. So we're going to plug this x value into the first equation. So I have y equals -2/3 x minus 4. So I'm going to replace x with -3. So y equals, a negative times a negative is a positive, and 2/3 times 3 is 2. So I have +2 minus 4, and 2 minus 4 is -2. So my y value is -2. On number 9, I do have a hint. We've talked about how a system is 2 or more equations. Here we have 3 equations, and I'm going to point them out really quickly. So number 9 says a farmer grows corn, tomatoes, and sunflowers on a 320-acre farm. Then it says this year the farmer wants to plant twice as many acres of tomatoes as acres of sunflowers. Also, the farmer wants to plant 40 more acres of corn than tomatoes. My question says, how many acres of each crop should the farmer plant? So the question tells you what your variables should be. Your variables, so let's call my variables x, y, and z. And let's say x is the number of acres of corn. I'm going to call y the number of acres of tomatoes. And finally, z will be my number of acres of sunflowers. So know that you're going to write three equations for the system, and then use substitution to solve for all three. This assignment will be due at the end of the class period. I will look at this tomorrow morning before class.